title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just Hyper Ruliad Turtles All the Way Down.
Yes, it's on the back of an infinite number of Hyper Ruliad turtles. I'm thinking of doing something really terrible here, which is that, James, you had fed me last night these ideas about Emes and the Hyper Ruliad.
Yes.
And I would enjoy chatting about that for a few minutes.
Well, sure. Here, I can stop sharing.
Okay. Well,
let's chat about that.
And this is okay. So everybody's welcome from our chemistry team to stick around. Although this is going to be weird, and it's going to be about a different So, as people may remember, so what I realized is, so what James commented on is in the Ruliad, the entangled limit of all possible computations. What is the raw material on which the Ruliad operates? The raw material are Emes, E-M-E-S, which are atoms of existence. And in the case of space, those are instantiated. We can think of those as atoms of space. Mm-hmm. So the issue is, and I'm going to go, we get to actually use this again. Thank goodness for that. Hyper Ruliad. It has not seen a lot of use yet. Okay, so James's observation is that the proof of uniqueness of an atom of existence, cannot be made in the context of the Ruliad alone, but requires regression to the Hyper Ruliad. Okay, so
just for some context, right? So Emes have to, they possess two properties. So the first is that they exist, which is important, and the second is that they have UUIDs. Okay, they have to exist because if Emes don't exist, they're the primordial building blocks of the Ruliad. So if Emes don't exist, then the Ruliad doesn't exist. But they also have to be unique, because if they're not unique, you can't distinguish between them. And I would say if you can't distinguish between the Emes, then there's no reason to say that there are multiple Emes, and then you basically have a big crunch in the Ruliad, and the whole thing will collapse. So you have to have both of them.
Go
ahead.
Okay, so first point about the Ruliad is one of the key issues is, the Ruliad in its rawest state trees out everything. Okay, but there are equivalences which make the Ruliad non-trivial. Okay, but those equivalences we have said those equivalences are being made by observers. Most of the equivalencing is done at the observer level. Okay, but so now what you're saying is that if you want to know, the equivalencing of Emes and the fact that they are not all equivalent, you're saying is something that is outside of the observer. The non-equivalence of Emes. In other words, being able to tell there are Emes that the observer can equivalence.
Yes.
The claim would be that going the other way, that maintaining the Emes as inequivalent is something not within the power of the observer. That is, an observer can equivalent. The claim would be an observer can equivalence Emes,
but only because they're by default unique in the Ruliad.
Right, can equivalence Emes for their own purposes.
Yes.
As an observer, but an observer can't establish the inequivalence of Emes. In other words, an observer can just say, look, I believe that something definite is happening, therefore I'm conflating all these different things.
Right. But the Ruliad can't even establish the...
That's correct. Okay, so let's look at the analogy to black holes. Okay, So I claim that, you know, the termination in a space-like singularity, termination of in a you know, at the center of a black hole, is where time stops. Right. So I think that there's a hierarchy of times. Okay, so actually, let's talk about this. So the hierarchy of time. Okay, so our usual time, you know, our usual time, you know, a Turing machine is, you know, a Turing machine works the way it usually does. Okay, so in the Hyper Ruliad, in the first level of the Hyper Ruliad, the level 1 Hyper Ruliad, a Turing machine, what would be infinite time for a Turing machine, you know, it infinitely compresses time for a Turing machine by being able to say that, you know, the halting problem for a Turing machine can be solved in the level 1 Hyper Ruliad.
Right.
Right, by having one level of oracle. Okay, but now let's go down to below our level. Below our level, time has stopped, or time is finite. So our, you know, in black hole time, time is finite. You only have a limited amount of time. So, i.e., it's equivalent to countable numbers in this case. Okay. In this case, it's equivalent to a finite set of numbers. Whereas in the level 1 Hyper Ruliad, it is, I don't actually know I would guess that's somewhere up the transfinite hierarchy. Don't know exactly how that works.
That sounds right.
Yeah. So time is somewhere in the transfinite hierarchy.
I mean, is it Aleph? Is it Aleph 1?
Don't know.
For the first Hyper Ruliad?
I don't know. That would be the obvious possibility, and that may be related to the continuum hypothesis, whether that's actually true or not. That's a thing to just figure out.
Yeah. Right.
But then, so my basic thought would be, if you're on black hole time, then I don't quite see how this works, but I'm kind of thinking that the Emes that is at the center of a black hole, that is eventually the Emes that you just stuck on that Emes. Yeah, I mean, okay, claim would be the Emes in a black hole, of which there are a finite number in some sense, can't determine, question mark, that they are distinct from the Emes in another black hole. I'm not sure if that's right, but I think.
What do you mean? Because time has stopped, so there's no computation by which.
No, I'm claiming that they have to be embedded. You know, the only way they can distinguish is by their embedding. The only form of distinction is their different position in the ordinary universe. But to understand that the fact that they have different positions in the ordinary universe is not something that can be determined, I claim, with a finite number, with time being finite in a single black hole. That isn't quite clean. That argument is not quite clean. But the thing that I was going for was, you know, the big question is, can the universe prove, aka the Ruliad, prove its existence and uniqueness? And the answer is undoubtedly no. Mm-hmm. And can it prove its completeness and consistency. So I think the consistency, that is, what would this mean? Yeah, can the Ruliad, okay, the completeness of the Ruliad is basically something about the connectedness of the Ruliad.
Yes.
Can it prove its connectedness?
Can't prove. I mean, I imagine the rule. It depends on how you want to define consistency. But if there are rules in the Ruliad where it's the same rule but it has different evaluation paths, well, that's inconsistency. The Ruliad's going to be wildly inconsistent because you have many rules that can be evaluated in different ways and give different outputs.
I see what you're saying. So you're saying if inconsistency is somehow, well, I don't know, it's somehow related to this equivalencing thing. But I think the thing that's sort of fun about this is just like if you're inside arithmetic, inside arithmetic, you just have to assume completeness, you just assume completeness and consistency. So I'm claiming.
Okay.
I mean, I don't know quite how this works, but I mean, I'm claiming that within the Ruliad, there is what amounts to an article of faith that the Emes are inequivalent, and that is ultimately unprovable in our universe. Would be the claim. And the only proof would be from looking from outside the universe from the Hyper Ruliad, which we can never do.
But if it was false, I mean, what I've presumed is that if the Emes aren't unique and they're somehow the same, well, then the Ruliad would collapse. So the fact that the Ruliad hasn't collapsed.
I don't think that's right. I think what's right.
Well, do you think it? I mean, imagine if Emes weren't actually unique. Do you think that the Ruliad would be able to stand? I don't think it would.
No, I don't think it would. I think that but remember, the raw Ruliad, everything is unique. It's just treeing everything out.
Well, but that's because the Emes are unique. Right?
Yes, okay. So the default case, assuming Emes are unique.
Yes.
We got to make Emes not be a spelling word. Anyway, and Ruliad. I mean, I'm kind of upset that Ruliad hasn't been added to the spelling dictionary yet. We need to get that done. Okay, the default case, the Ruliad, I'll make some silly joke about it, but okay. The default case, assuming the Emes are unique, is everything gets treed out. But then the observer, which is no good to us, then observers do trivial or quotes trivial or non-trivial equivalencing. By trivial equivalencing, I mean that the state is the same, the graph is isomorphic, those kinds of things, which seem to us like things that you couldn't fail to do. Like if the graph is isomorphic, if the graph of the universe is isomorphic, it's the same universe, we would think.
Right. But that's just because we do it by necessity, because we're computationally bounded.
Yes. But I mean, the question is, your statement is, if the Emes were not in fact distinct, see, I have this feeling that the only way you can tell that they're not distinct is in the Hyper Ruliad.
The only way that you can tell that they're not distinct.
Well, you're saying if they were the same, if they were not unique,
Yeah.
then your claim is that you cannot support that the observer would never consistently be able to set things up with the assumption they were distinct. That assumption would eventually fail.
If they're not distinct, then they're the same, right?
Yeah.
And if they're the same, I don't see how you can build a rule. I mean, you wanted Emes to have UUIDs for a particular reason. If they're all the same, I don't see why the Ruliad doesn't just collapse into a single Emes.
I agree. I think it does. Yeah, right. So I mean,
right. So the point is that somewhat. So the point is that you have to get the UUIDs from outside the Ruliad, right? They're being imported from the Hyper Ruliad, and I think that's what Hyper Emes do. So the Hyper Emes are the Hyper Ruliad, and they do the undecidable computation, or they are the undecidable computation that assigns a UUID to each Emes. No, and that makes it so. Oh yeah,
no,
yeah,
right. But I mean, this is relevant to the existence of the universe, because, I mean, if all the Emes were non-unique, then there is no possibility for existence in the universe.
That's right.
So that kind of throws you into something which I always suspected was the case, that the proof that the universe exists, in other words, that the Emes are unique, that proof somehow has to live outside the universe.
Right. That's probably why there's, theology and these other kinds of fields, maybe.
Well, I mean, the point is that the argument for the existence of the universe that I've been making is, the claim is that the Ruliad necessarily exists. Your claim is there's an assumption required in the claim that the Ruliad necessarily exists, which is that any atoms of existence, any distinct atoms of existence exist. If the atoms of existence can't be proved to be distinct, then your claim is that the formal necessity of the existence of the Ruliad depends on an assumption that it is possible to have distinct things.
Yes. And in taking that further, it means that if the Ruliad exists, then the Hyper Ruliad also necessarily exists. See, before, the Hyper Ruliad was something, at least as I understood it, where we're thinking, okay, well, what about hypercomputation? Well, let's put that in the Hyper Ruliad. But now there's there's a stronger statement, which is you actually need the Hyper Ruliad, and the concrete support provided by the Hyper Ruliad is at the level of the Hyper Emes, which give uniqueness to the Emes.
If things could never be distinct, there could be no Ruliad.
Right.
And there could be no existence in general.
That's right.
But the fact that things can be distinct and that they can be proved to be distinct, you claim rests on this infinite tower of Hyper Ruliads.
Yeah. Yeah, because then the hyper Emes have to be distinct too. They're going to depend on some hyper Ruliad, et cetera, et cetera.
Okay, so the possibility of a distinctness then depends on infinite hierarchy of Hyper Ruliads. This is so frigging theological. It's crazy. I mean, I bet that there's actual arguments from 500,000 years ago or something about exactly these types of things, about
Well,
what do you get if, you know, it's either that or mathematical logic. Take your pick. It's either the theologians or the mathematical logic people who might have thought about this and come up with something reasonable. I'm kind of going to bet on the theologians between those two. Sorry to mathematical logic people here.
well, I remember you gave this talk a few weeks ago, and the title of the talk was "One Ruliad to Rule Them All."
I didn't make up that title. Yeah,
okay,
right.
That was the title, right? But I think the actual title of the conference was something like "Ground Truth" or "Turtles All the Way Down." And so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper Rulial turtles all the way down.
Yes, it's on the back of an infinite number of Hyper Rulial turtles. No, it is interesting. The concept that the possibility of existence depends on things that we are permanently unable to, concretely. Yeah, I mean, it basically, where we can never know. That's interesting. I mean, in other words, humph. Well, this is it puts another twist on the whole "why does the universe exist" question. As I say, because you're saying that the existence of the Ruliad depends on an assumption, and that assumption can only be justified outside of the Ruliad.
Yeah, I mean, it's almost an axiom. It's like an axiom of uniqueness for Emes.
It is. It's an article of faith about the Ruliad, basically. If you assume that, you're basically assuming two facts. One is a contingent fact. We are in the Ruliad rather than Hyper Ruliad. That is where we happen to, where we as observers happen to hang out, just as we happen to hang out in this particular galaxy. And that's point one. And point two, you're adding the additional idea that that it has to be possible to make a distinction between things.
Yes. I don't even know if it's an assumption. It's just a structural requirement in order to have the Ruliad. But that structural requirement,
I know, but it might be right. But it might be the case that that structural requirement is. I mean, how could that fail? Because I would argue that the same argument that leads to the Ruliad also leads to all the Hyper Ruliads. That is the same argument of formal necessity leads to all the Hyper Ruliads. But your point then is that fine, that's all well and good. I see. So the main point here is that there's a shadow of the infinite tower of Hyper Ruliads that is a shadow into the Ruliad. That is what causes the Ruliad not to collapse. So okay, so the claim would be the non-collapse of the Ruliad is a shadow of the tower of Hyper Ruliads.
Yep.
And the analogy of that for a black hole, I'm not quite sure about, but I bet there's an analogy, and I'm really late for something else.
One other, not to induce vertigo, but one other provocation. If we were observers in the Hyper Ruliad, would we just think that we're in the Ruliad and that the next Hyper Ruliad down was actually just the Hyper Ruliad?
Okay, that's a good question. If we were, in fact, in the Hyper Ruliad, would we know it?
And if you don't, then what it means is we have absolutely no idea where in the tower we are.
Let's think about that for a second. I mean, we pretty much know we're not, at the base level, in a black hole where time stops. We know we're not in a thing where time stops. Because, yeah. Look, here's the point. The point is, observers like us believe we persist in time, and we have a decent amount of time for which we persist. That is, we don't just persist for
we're not Boltzmann brains, right? Yeah. We're not ephemeral.
Right. And okay, so we believe we persist for a decent amount of time, but in the Hyper Ruliad, I think the analogy would be that we believe we persist for a certain amount of transfinite time. And the question is, can we tell the difference between persisting within a Hyper Ruliad where everything is operating in transfinite time?
Right.
Can we tell the difference between that and the case where we are in countable time, so to speak?
Yeah, right. I mean, if we're just computationally bounded and we're in the Ruliad, or if we're hyper computationally bounded and we're in the Hyper Ruliad, would that feel any different to an observer?
I bet it does. I bet it does, because I bet it does around black holes. I bet that there is insofar as black holes are a base, but I bet we may not even know the answer yet between those two.
What do you mean by base, by the way?
Well, I claim that zero, which is, in the end, time in a black hole just stops.
Are you saying that time having stopped in the black hole, is that something that you're saying is kind of threaded across these different Ruliads, like it's common to them, or something?
No, I think that to the Hyper Ruliad, they will be saying, look at that black hole in the Hyper Ruliad. It's just a Ruliad where time, which we can't see into because it has an event horizon, but where those poor schmoes in the Ruliad, they are living only in non-transfinite time. We say those poor schmoes in the black hole, they have only a finite lifetime. They're going to just stop.
Yes.
And to the Hyper Rulians, so to speak, the pure Rulians.
We're like a black. Yeah.
Yeah. We have this. Our experience of time is, those poor Rulians there, they can't tell that this Turing machine is going to halt or something, or they can't. Yeah. Anyway, more to think about here. I'm sorry. This was sort of a distraction, but you never can. If we didn't have
it's good to celebrate the fact that the Ruliad hasn't collapsed. Taking some time to celebrate that seems worthwhile.
And that we're not right. That we are. Well, we believe that. Yes, we believe we have. See, we think we're all good. We have an infinite time to figure everything out in our universe. But to the Hyperulians, they're like, what do you mean you have an infinite time to figure things out? We can figure out, we have oracles for all our Turing machines. So your infinite time is going to get you basically nowhere relative to where you can get to in hyper time, so to speak.
I know, but then the hyper observers have the same.
I know it's all it's a chain of
of disdain. Yeah, right.
But what about going the other way? Is there a sub-Ruliad?
No, because that's what black holes are.
Okay. And then one question, maybe my physics is really, really rusty, but as you approach the speed of light, time slows down. So if time has stopped, you're going as fast as the speed of light or faster?
No, what happens is near a black hole, the light cones tip over. So you're basically at a state. What in our models, it's pretty easy to understand what happens at the center of a black hole or a space-like singularity, which is that the rewrite rules just don't apply anymore.
Okay.
So that's it. Time is over. at that point, because time is the progressive, the fact that we are having a discussion and having the experiences we're having is a reflection of the fact that we are continuing to compute.
Yeah. Yeah. So if time stops, you're no longer evaluating rules.
Right. So your computer, for example, just says, if you shut your computer down or then as far as it's concerned, time has stopped. So this is the point is that a hyper time observer, has disdain for the pure time observers in our universe. That is, imagine all the science you can do if you can solve every halting problem. And that's the case. Imagine the level of science if you can solve every halting problem, because that means there is no computational irreducibility it's very amusing. I get a spam call, and its caller ID is Oracle. I think that is
it's a disdainful call.
That really is quite something.
Oh man.
I mean, maybe it's an Oracle salesperson, although calling random numbers, because that's or alternatively, it's precisely this. We finally cracked it, and yeah. Anyway, if you could solve every halting problem, which means, i.e., there is no computational irreducibility.